Hi, my name is Darren, and today I'm going to talk about elementary row operations from matrix. A matrix is a rectangular array of numbers. In other words, numbers are grouped into rows and columns. We use matrix to represent and solve systems of linear equations. For example, the system of equations can be represented by what is called an augmented matrix. The augmented matrix can be written in the form of So the first column indicated as x, the second column can be indicated as y, and the third column can be indicated as z, according to the example above. So the fourth column we can indicate as constant. So for the row number 1 is write as the first equation from the example above. Then the row number 2 is for the second equation. Then the third row is for third equation. So according to the example above, we can write the system of equations above into augmented matrix like this. So remember to place a 0 in the matrix if the coefficient of a variable is 0. Like the first equation does not have any coefficient for z, for x. So we put 0 here. Coefficients of 3 unknown variables x, y, and z, and the constant terms are placed in their respective place in the matrix. Solving a system of equations using a matrix means using row operations to get a matrix into the form called reduced row echelon form, like the example below. Make sure only ones are on the diagonal with zeros every other position except for the last column. The last column can be any numbers. Then we will move to the type of row operations. There are 3 types of row operations. We can perform elementary row operations on a matrix to solve the system of linear equations it represents. The first type of row operation is interchanging 2 rows. Rows can be moved around by switching any 2. In order to get the matrix into the form called reduced row echelon form, we need to make sure the first row and first column's number to be 1. So in this example, we just need to interchange the row number 1 and row number 2. Then we will get a new matrix. The second type of row operation is multiplying a row by non-zero constant. We can multiply any row by any number except 0. When a row is multiplied by a number, every element in that row must be multiplied by the same number. In the example here, row number 2 is multiplied by 2 to get new row number 2. So zero multiplied 2 is 0. 8 multiplied 2 is 16. 16 multiplied by 2 is 22. 0 multiplied by 2 is still 0. In this case, the first row and third row is not affected, so we just copy it directly. Then we get a new matrix. The third type of row operation is adding a multiple of a row to another row. We may also multiply a row by any number except 0 and add the results to the another row. In this example, we multiply the row number 1 by 4 and add the answer to row number 3 to get a new row number 3. So row number 1 is 1, 0, negative 3, 1. So if we multiply it by 4, we will get 4, 0, negative 12, 4. Then the next step is add this answer to the original row number 3. So we will get 4 add to negative 4 is 0. 0 add to negative 0 add to 14 is 14. Negative 12 add to 2 is negative 10. 4 add to 6 is 10. So this is the new element in new row 3. So we can write in the form that is the first row and second row is not affected in this case, so we just create. Reminder, row 1 never changed. We only multiply row 1 by 4 so that we could add the product to row number 3. And there was no intention of keeping the product as a part of the new matrix. After introducing the type of row operations, our group member is going to give some examples on how to apply it to solve system of equations using matrix. Thank you.
Hi, I am Ming. So previously, Darren talked about the basic theory of echelon row form. There are several uses of elementary row operation, which includes finding the inverse of the matrix, solving linear equations, and more. So now, Justin and I are going to demonstrate you some simple elementary row operation. Okay, let's take a look at this question. So, given that the matrix A is as shown, perform the operation consecutively. As we can see, we are required to do 5 operations, which B is in terms of the row. So the first operation, B1 interchanging with B2. Interchanging rows are easy, so let's switch the rows. Okay, so let's take a look at the second operation, B2 plus negative 2B1. Okay. By performing simple calculations on B1, so adding the multiplication into B2, so we will get the answer. Next, I'll pass it to Justin to complete the operations.
Hi, I'm Justin, and now I'll continue on with the third operation of this example. 3 times row 1 plus row 3. So we'll use this matrix to continue with the operation. So 1, 2, so our operation, 3 times row 1 plus row 3. So for this operation, the first 2 rows won't be affected, so we can straight away copy it down. As for the third row, when we sub our and we sub our digits into the operation, here we will get 0, 7 and 5. So let's move on to the next operation, which is third row plus -7 times second row. So our operation, third row plus -7 times second row. So the same thing, the first two rows are not affected by this operation, so we can straight away copy it out. As for the last row, when we sub into this operation, the first digit is 0, so it's 0 for here and here, so it won't be affected. So here we can straight away write 0, and for the last two digits it will be 0 and -2. So finally, to our last operation, which is -1/2 times row 3. So our operation, -1/2 times row 3. So this operation does not affect the first two rows, so we can straight away copy. As for the last row, the first two digits are 0, so it won't be affected if we sub into this operation, so we can straight away write it down. As for the last number, when we sub into this operation, we will get 1. So this will be the final answer for the example. Thank you.